Welcome, everyone, and thank you so much for joining us for our afternoon session today. I'm very excited to be able to introduce you all to David. And without further ado, I'm going to turn the time over to you now, David. Thank you.
Perfect. Thank you very much. Hey, everybody. I'm David Joy. I am part of the Weber School District. I am also a student up at Utah State. I just finished my PhD up at Utah State, focusing on outdoor education and social justice. But I decided I wasn't done with school and wanted to get my administrative degree. So decided to add another year on. So still going to school and still teaching. I apologize if the intercom goes off. I am at my school, and so we're at the end of the day. The students just left, so there's a pretty good chance that there will be a few announcements made here and there. So I decided today to focus on the topic of teaching with phenomena. I've been teaching 8th grade and now physics for quite a few years. So I've been able to use the new Utah Seed standards for a while. And I thought that it would be kind of fun to focus on phenomena that we could use in an environmental education setting. So that's kind of what I'm looking at. There on the screen, I've got a list of stuff. If you want to, I'm going to do a couple of examples. I tried to pick an example from each of the different age levels. If you would like to play along, then you'll just need a piece of white paper and a piece of black or dark paper, like construction paper. You'll need to know where you can find a plant with seeds outside. So just kind of in the back of your mind, think of where you might be able to find a plant that still has seeds. I know it's kind of tricky this time of year, but there are still some dandelions and stuff out there, or maple trees or that type of thing. And then you'll need to know in the back of your mind where something outside is that is rusty. So anything that's rusty outside, like for me, I know it's the side of my Jeep. I've got a big old rust spot on the side of that. So that's my personal item with that. One of the things that I would like you to do, I'm going to give you a couple of minutes. If you do have that piece of white and black paper, you're going to want to put it outside. It's not super sunny right now, but I'm hoping this will still work. So if you do have the white and the dark paper and you want to run it outside, I'll go ahead and take just a 2-minute break to let you do that so that you can get it outside. I'm going to go put mine outside too. So we'll just go ahead and wait for about 30 more seconds in case people are still sticking their pieces of paper outside. Okay, so get this. I always like to show what picture I use for my background when I do different presentations. This is a picture of some of my students that I took down to Lower Calf Creek Falls, down in Grand Staircase. If you've ever made the hike, it's really a cool experience. As you come through the canyon, you come around the corner and you're greeted with this view. And so even though I've seen it a bunch of times, each time it's pretty incredible. But this time it was really cool because I was with a group of students, and this was part of my dissertation that I did. So just kind of a fun little bit of information. One of the things we're going to be using on this presentation is Google Jamboard. It's just kind of a collaborative app that you can work together on. And so I'm going to put the link in the chat. And if you want to go ahead and head to that Jamboard, I'd like you to just take a couple minutes to write down what your definition of phenomenon is. And so your best guess, or your best definition of what phenomena is. Let me get that pulled up here.
So David, I think when I clicked on it, it seemed view only. I don't know if that's just me.
Oh, okay. Let me get that to, let me change. Let me change that to editor. Okay, hopefully that is done now. Is that letting people edit now? Okay, so if you've never used Jamboard before, at the top, there's a spot where you can click through. I've got 10 different boards up. We're going to be doing some different things with it. Off to the side, you have your different controls. You can use a pen. There's the eraser. I like the sticky notes a lot. It's just kind of a quick way to add stuff to them. Or there's text boxes. You can create shapes or add pictures. It's got a lot of different features. But if you want to just go ahead and take a couple of seconds and write down your best guess definition of what a phenomenon is. Okay, we'll do about another 40 seconds. Thank you for everybody who's adding your definitions in there. I really appreciate it. Okay, so as we're looking at these, we have a lot in common on our definitions of phenomena. Something that's observable, something that happens in the natural world, sudden occurrence. So I think we're definitely on the right track with what phenomena are. So let's go back here. Okay, so my experience with teaching with phenomena comes mainly through the Utah Science and Engineering Education Standards, the SEED standards. And so that's kind of the direction that I'm coming with this from, and so I'm going to teach from that direction as well. They're based off of the next generation science standards. It's kind of, if you're in science education, it's kind of pretty much well known that they are the next generation science standards. We just changed some wording to make some legislators happy, which you have to do what you have to do. They incorporate three-dimensional science. So they look at the cross-cutting concepts, which are those things that we find in all science. So energy and matter, patterns, that type of thing. So they're the things that, for me as a teacher, I really kind of focus on, because they're the things that no matter what science class they take after my science class, they're going to talk about those things. So they're one of the main focuses. And then you have the science and engineering practices. The way I explain that to my students is that's the stuff that scientists actually do. That's the things that scientists and engineers are doing that make it so they're doing science and engineering. So asking questions, looking for patterns, modeling, computational thinking, that type of stuff. And those seed standards are now in place, kindergarten through 12th grade. They were, for a while, they were only 6th through 8th grade. I used to know the rationale for why they started in the middle, but I can't remember. But I liked it because it gave me a chance to kind of get a head start on it. So I've actually been using the seed standards for several years now. And then it's kind of nice because as I moved into teaching physics this year, I already had the practice for the new seed standards for the physics classes. I have the link, let me go back here. I have the link on there and it's in the resources part of the Jamboard, that last slide, for how you can get to the actual seed standards if you're interested in it. They're pretty loaded. You have to kind of go through them and break them apart so that they're easier to understand. But if you want to see what the actual standards are, that's a quick link to them from the state office. So I know it's awful to put a whole lot of text on a slide during a presentation.
We still are seeing the Jamboard.
Oh, me would help if I actually, thank you for telling me that. Is that better? Did that go back to the presentation? Yeah. Okay. So let me get here. So there's the information on the seed standards that I thought you were all seeing, but that I didn't have on there. So I know it's awful to put, like I was saying, I know it's awful to put a lot of text on, but these next couple of slides are kind of the rationale behind why we use phenomena to teach science, and therefore why we should be using phenomena a lot in our environmental education, as we're teaching students about the environment, whether it's formally or informally. We really need to focus on phenomena, because hopefully I can convince you of why with these next couple of slides. I've always liked this quote from Einstein: the important thing is to not stop questioning. Curiosity has its own reason for existing. I tell my students that's the most important part of science, right? From the beginning of the year, is being curious and asking questions. It's always one of their favorite quiz questions. I always ask them, what's the most important part of science? And I talk about it so much that they all know it really well. So this other quote comes from this book, which was written by Brett Molding, Roger Bybee, and Nicole Paulson, who are the just geniuses behind the seed standards and did a lot with NGSS. Brett Molding is here locally. He's amazing. If you ever get a chance to do a workshop or anything with Brett Molding, it definitely would be worth your time. But a couple of these quotes come from that book. I have the information for that book again on the Jamboard on the resources. It's a great way to look at more in depth why we do what we do with this. But in that, he says, curiosity plays an important role in teaching and learning. Teachers' understanding of ways to utilize this natural aspect of learning plays an important role in science education. Even more important is the ability to sustain students' curiosity and build curiosity into interest in science phenomena. So we're using that natural curiosity that students hopefully have in order to get them interested in what it is we're trying to teach them. So we're capitalizing on that natural desire to learn things and to ask questions. And we do that by catching their interest with some sort of phenomenon. And the way it used to be is we'd show them something and we'd immediately move into explaining it. Whereas it's so much better for the students and it's so much more interesting to them if we show them something and we act like we don't know and we help them to figure it out for themselves. It teaches a whole lot of things like critical thinking and questioning, and keeps them interested and curious. They do so much better if we don't just sit there and tell them the answers. This is a definition of phenomenon from thewonderofscience.com. It's a really good resource. They have a really cool master list of phenomena. So if you're in a setting where you're trying to teach something and you don't know a phenomena that can go with it, they have this huge master list broken down by grade level. It is by NGSS grade level, but like I said, it pairs up fairly well with the Utah Seed Standards. With a little bit of searching, you can find your way around. But they have a really great master list that you can add to of different phenomena that fit for different topics. And so it's a lot of fun to go on there and just see what people are adding. But like most of you put on that first Jamboard, phenomena are just simply something that we can look at, an observable event. They don't have to be flashy. They don't have to be complex, or I mean, they don't have to be, I don't know, they don't, too often we get too caught up and they need to be super complex and hard to figure out and take the students a long time, when really they just need to be something that the students can work through. It needs to be something that they don't immediately know the answer to, but it needs to be something that takes a little bit of time, but is still on the level for their learning. This is another quote from that book by Brett Molding and Roger Bybee and Nicole Paulson. And it's a little bit more into why we use phenomena to teach. And again, it goes back to, it's part of human nature to try to make sense of something that we don't understand. It used to be a survival mechanism for us back when we were wandering around and staying in caves, but we still have that. We still see something and we naturally want to figure out what is happening and why it happened. And so rather than just telling students about it, we use that. And as we do that, we help them to develop a whole bunch of other skills and make them better at trying to figure things out and problem solve and think critically and question things, and not just take it for granted that it's true because it was posted on Facebook. So this for me, this slide right here for me was like a huge aha moment for me when I was first starting this. I was in a district workshop and I was really struggling with the idea of, how do I constantly come up with some amazing phenomenon that's going to catch their attention all the time, and was just really overwhelmed with it. And I went to this workshop and they had this almost just like this, just on the board: phenomena doesn't need to be phenomenal. And I was like, yeah, it does, or else it's not phenomena. And as we went through that particular workshop, they actually had us just dump rubbing alcohol on the desk and watch it evaporate. And I remember thinking, holy cow, like, this is a phenomenon. We dump this liquid on this table and pretty quickly it goes away. And when we stopped to really look at it and we started to ask the questions, because the way you do this, and we'll talk about this more in a second, you present the phenomena and then you let the students start to question it. And you just write down all the questions that they can think of. And as we did that, I realized I had a lot more questions than I thought about just simply dumping rubbing alcohol on the desk. And I mean, I even knew why it did what it did, but I don't know, it was a lot of fun. And so this was a huge part for me. And so I wanted to make sure I included this. It doesn't need to be phenomenal. It can be just something that catches their attention, and it may not catch their attention at first. It may be that they're like, oh, I think I know what that is. But as you get them to ask questions, and especially as you guide them through by kind of steering their questions in the direction that you want, they may start to really kind of question things more and more. And then as they start to question it, they gain more and more interest because they realize they may not understand that. And sometimes you have to set things up. I did something with my physics students where we hung a weight off of a string, and then we had a string hanging off the bottom. And if you pull the string quickly, the bottom string breaks. But if you pull the string slowly, the top string breaks. And I set that up for them with this is a model for something you use every day in your life. Every day in your life, you're doing this physics phenomenon and you don't even realize it. And that's kind of what caught their attention. And so then I had it set up, and I asked them, okay, if I pull slowly, what's going to happen? And they all knew the string would break. I was okay, now if I pull quickly, and it was about half and half on whether they knew the top string would break or the bottom string would break. And so then I pulled it quickly and the bottom string broke, and we talked through it. And we went through the forces and the whole lesson. And then I told them the place that you use this in your everyday life is your toilet paper roll. If you pull it slowly, the whole thing's going to unravel. But if you pull it quickly, then it breaks off one sheet, unless you're at the school where the whole thing still comes. So sometimes you just have to know how to catch their attention, how to get them focused on that phenomenon. These are just a couple of tips and ideas that I found with phenomena, and then we'll get into trying some out. It's very student-centered. Like, the students are at the center of this. It needs to be them looking at the phenomena. It needs to be hands-on. It needs to be, as much as it can be right now, that's a little bit tricky. I tell my students this is a sucky time to be in science because we have to not be hands-on. But it needs to be them asking the questions and you just guiding them in the direction that you want, okay? So you introduce the phenomena and then focus on student-generated questions, and you're guiding them along the way. We hear it a lot as teachers, and so I'm sure a lot of you have heard it. You're the guide on the side and not the sage on the stage. You're not just up there showing off how much you know. You're helping them to learn the stuff by just guiding them to figure it out themselves. You're giving them maybe a quick article to read, and maybe that'll spark a question for them, or maybe you'll show them a quick YouTube video and that'll help them to think, oh, okay, what about this? And so you're just kind of guiding them along. You want to pick phenomena that students have some background experience in to build off of. And knowledge, the way humans generate knowledge is we have to connect things to things we already know about and things we already have experience with. If we don't have any experience with something, if we don't know anything about it, then we're going to really struggle to learn from that. And with that, you've got to be aware of things like culture and socioeconomic status and background and things like that. I really screwed this up one time. I moved to a new school and I was talking, and we were talking about ecosystems. And so my plan was to move into when they reintroduced the wolves in the Yellowstone ecosystem. And so I was talking about Yellowstone and was just assuming everybody had been to Yellowstone, because for most of my growing up, every summer we went to Yellowstone. And I looked out and I realized I had a whole bunch of blank stares from my students, and I asked them, how many of you have been to Yellowstone? And only one kid raised his hand. And I was like, well, okay, this is not going to work at all because you have no idea what I'm talking about. And so I had to really quick pivot to something else that they had experience with. And I actually pivoted to Antelope Island because I knew in 4th grade they had gone to Antelope Island on a field trip. It wasn't a smooth transition by any means, but we were able to make it work, and it made it make a lot more sense to them because they had that background, whereas they had maybe seen a picture of Old Faithful, and that was the extent of their background for Yellowstone. Not all phenomena are the same. You have your anchoring phenomena that's like your main idea phenomena. That's the one that you're going to keep coming back to. And if you're in an informal situation, you may not have the students for very long. And so you may just pick one, like an investigative phenomena, which is it's a shorter phenomena. It's a little bit quicker to get to the answer, or maybe an everyday phenomena. They're a little bit quicker to get to the answer, but they require less work, kind of less effort to get to that answer. That anchoring phenomena is usually one that takes several days. It's kind of, for me, we have the everyday phenomena. I try to show them something that applies to what we're talking about every day. We have the investigative phenomena. That's kind of our week-long phenomena that we're coming back to. And then we have our anchoring phenomena, which is like the unit phenomena. What's the whole point of this? What are we going to end up understanding better by the time we're done with all of this? So I have talked a lot, which I really try not to do, but let's go ahead and let's do some of this together. So I tried to pick a phenomena for each different level in a variety of areas. So this first one is a kindergarten standard, and that's the paper that you just put outside if you're playing along at home. So what you're going to want to do is go outside and find your white paper and your dark paper and make as many observations you can of your two. We'll do this for about 4 minutes using your senses. And I always tell my students, if you're at school or if you don't know if it's safe, maybe don't use taste, but if you want to lick your papers, go for it. But use your senses. Don't just use touch, but use all of your senses, and then come up with some questions that you have about those papers. Okay, and especially questions that compare and contrast the two papers. And then come back, and on the Jamboard, there is, so let me head back here. Did that switch for everybody? Are you seeing the Jamboard now?
Yes, we are.
Okay, thank you. So you're going to have a spot where you can write some observations about your paper and then what questions you have about the paper. And you just switch by the arrows at the top. So go ahead and take 4 minutes to head out and check out your papers. I'm going to go do the same thing with mine. Okay, so we got about 2 minutes left. So if you want to add your observations and if you want to add your questions that you have. Okay, so we got a lot of good observations on there. Okay, and we got a couple of good questions on there. So if this one is a little bit tricky for me because I've never taught anything lower than 7th grade, but imagining that we're kindergartners, this, you may have kind of guessed where I would be headed with this, but we would be doing a lot of asking questions about what did they look like, what did they feel like, and then we would, as a teacher, I would start to direct them to what the weather was like and maybe what was causing these different things. So this kindergarten standard is all about weather. And so I would, if I were teaching this with a group of kindergartners, I would ask them maybe, okay, well, what's the weather like right now? And right now is not great. We didn't have them out there for a very long time, and there's not a lot of sunlight. So if we had them outside for a lot longer and there was more sunlight, I think this would be more pronounced. But ultimately, once a kid talked about, oh, they feel differently, the darker one's warmer, then you would kind of grab onto that and be like, oh, why do you think the darker one's warmer? And hopefully, as soon as you did that, other kids would start to think about that, and you would just build off of that question. And oh, sorry.
Teachers, looks like the snow is about ready to show up, so we're just you marked on everything, and you can wrap things up. Have a great weekend.
I love our principal. He does that all the time. So, but you would start to steer them in that idea of, okay, one of the papers, the darker paper is warmer than the lighter paper. And then you would try to ask them why and ask them what about outside would maybe make that. And hopefully after some time, they would come to the idea that the light was doing it. And you could maybe use their shirts. And if a kid has a dark shirt versus a light shirt, or you could ask them if they've ever noticed that difference, or if they have part of their shirts light or part of their shirts dark, and you would kind of steer them in that direction. Okay, so let's go ahead and let's look at our next one. It's a little bit more complex. It's in 8th grade. Did that switch? Okay, I'm starting to get the hang of this, I think. So the next one is an 8th grade standard. This is one that I've used quite a bit, but I want you to go outside and find a seed and then look at the plant that it came from. Hopefully you have them together. And I want you to make as many observations using your senses as you can. Don't eat plants if you don't know if they're edible or not. So, but make as many observations as you can. And then again, we'll come back, and this time I want you to write down a hypothesis on the Google Jamboard that tries to explain how you think that seed turned into the plant, focusing on where the matter comes from. So look at the seed and then look at the plant it turned into, and then see if you can make a guess. This is just your first guess as to where that matter came from. And then on the next slide on the Jamboard, just like before, write down any questions that you have. So we have our hypothesis board and we have our questions board. Okay, so again, 4 minutes on that one. Okay, so as we're starting to come back, we've got a couple of questions coming up on the question board. We've got some good observations coming in on the hypothesis board. So I'll give you a couple more seconds to do that. Okay, so I I love doing this one because we have a really cool scarlet hawthorn right outside my classroom, and so I love that tree. Um, and as we do this, I try to get the students to focus on the fact that I grabbed one of the little berries here. Um, that's not even the seed. The seed's on the inside. It's quite a bit smaller than that, and yet we did some trig one time and figured out that the tree's about 19 feet tall. It's a big tree, big beautiful tree, and it came from this tiny little seed. And so I try to get them to think and try to come up with an idea of where does it get all this stuff. We've at this point in the year, we will have talked about the law of conservation of matter. You can't create or destroy matter out of nothing. And so that matter has to come from somewhere. The tree had to get the carbon and get the nitrogen and the different things to build the cellulose to turn into this tree from somewhere. And so we go into a whole bunch of questions about it. And they almost always bring up absorbing it through the roots, which is what I thought the first time. And okay, well, what about plants that live and float on top of water like lily pads? And then we go into that and we talk about different things like succulents and and asexual reproduction and things like that. And we eventually they get a lot of it through the air, a lot of the carbon from the carbon dioxide through the air. And so you have to be prepared for a lot of the questions. I usually have a lot of different pictures already pulled up, having done this for a few years. I know some of the questions they're going to come up with, and so I try to show them different plants that don't fit with what their hypothesis is, kind of an outlier to their hypothesis, and we work through that. I also really like to show them the seed of a sequoia and then what they turn into, and talk about the fact that you've got this tiny little seed that turns into this enormous tree, and it's through the same process. And so that's one of my favorite phenomena that I use for 8th grade, because it really does. It grabs their attention and they really like that one. Just in the interest of time, I think we're going to skip the next one, but I'll show you what it was. Let me pull this back up. So the next one was a chemistry standard. I really believe any class could be taught outside, and so I tried to pick one that would be a little bit trickier for a teacher. So I picked a chemistry standard, which I've heard a lot of chemistry teachers, well, I can't teach outside. Like, no, yeah, you can. Any class really can be. This one, I was going to have you just go out and find your rusty object. For me, it's the gate that we close to keep the kids off of the fields. It's got a part that's rusty and it's got a part that's not. And I was going to have you focus on how the rusty part was different from the not rusty part. And eventually you would work your way into figuring out, you would work your way through with the students and help them to figure out that when you have that chemical change, when that iron turns into rust, it changes the properties of the material. And so we would look at how the properties of rust are different from the properties of iron. So we'll skip that part for right now, because I would like for us to go back to the Jamboard, and how at this point I want to know want to learn from all of you. And so I have a slide for different phenomena ideas you have, especially related to your different organizations. And so the different organizations that you all are part of, I know, have tons of different ideas for phenomena, and it would be really helpful for different science teachers to see what you have available. Tag your organization in those, and I'll share it out with all of the teachers that I know and through USTA, Utah Science Teachers Association and stuff. And then on the next slide, tips and tricks and ideas you have for teaching with using phenomena. We kind of had to hurry through this, but if you have stuff that I didn't talk about in here, different ideas that you have for how to teach different phenomena, then add those on there. So we skip to the rusty part. So ideas that you have, especially related to your different organizations, and then a spot for tips, tricks, or ideas you have for teaching with phenomena. So let's go ahead and take like 4 minutes. I'm running really low on time. Let's take like 4 minutes and just throw some of those on there, and then we'll kind of wrap up after that. Also, while you're at it, I realized if you know of other resources that I don't have on here, I have where you can find the seed standards. I have, let's see, I'm trying to remember what this one was. I have them in my drive. Oh, the second one is that master list of different phenomena from that Wonders of Science page. The seed storylines was done by Davis School District, and it's a really great place to go, and it's done by grade level or subject and by standard, and they have some really great phenomena in there. And then this last one is from NGSS. It's just kind of a how to teach with phenomena worksheet. It's only like 3 pages long. It's really a pretty quick read, but it's got some really great ideas on how to teach with different phenomena. So if you have, and I added another page here so that if we fill up this one, we can move on to the next page for resources. But if you have other resources that I don't have on there, please feel free to add those on there. And as we do that, I'm going to add the link for the Jamboard into the chat so that let's see, so that you can make a copy of it here. So that you can keep all of this that we came up with together.
David, I had a question for you. I guess Have you found different certain topics or things that you're teaching where teaching with phenomena is, challenging or maybe not possible?
I haven't found any that it's not possible for yet, but I've had almost all of them. It's taken quite a bit of front loading on my part, of really doing some research and looking around. As NGSS and the seed standards have been around longer, there's a lot more sharing of stuff. And so with a little bit of research now, I can usually find something that'll work. Sometimes I've had a lot of times where I'll pick a phenomena and it'll just flop with the kids. And so then they're just not, I can't get them interested in it as much as I would like. And so then I try something else. And that's where the everyday phenomena really help. There's a really good TED talk on when you teach science, try and do at least some sort of a demonstration every day, which that's one of the things I'm working on this year. And I picked a really crappy year to start that because there's so much going on, but it's really helped with that idea of presenting them with a phenomena. So I haven't found anything that I can't find something for at all, but I've had a lot of stuff that I've really had to do some work to get something. Does that answer your question?
Yeah, definitely. That's helpful.
Okay, so by my timer, we're down to just a minute left. So thank you, everybody. Hopefully this was helpful. Hopefully you at least got something out of it. Really, I can't talk up teaching with phenomena enough. It helps make them better scientists. And as I've been trying to teach more and more outside, I feel it also helps make them better naturalists. They really are asking a lot more questions. They're noticing a lot more stuff. They're being a lot more observant. And so teaching with phenomena really is great in helping get our kids to where we really want them to be and to actually learn science rather than just a bunch of trivia about science. So thank you for your time and for your contributions to this. I really appreciate it. It makes it so much easier as a presenter. So thank you very much, everybody.
Thank you, David.